Hello, welcome back. Well, in the previous video we stopped here, okay, where we have seen the load transfer of two-way slab. So here from panel 1 and panel 2, panel 3, we have seen that this much load is going to be transferred, and the day load from this slab and this slab, the sum is 23.26, and the live load will be here 12.32. In the same way, I have calculated the load transfer from panel 2 and panel 4, and my final result is this. So here you see, in the same manner, here on this beam there will be a dead load here and dead load here, so the sum of them will be applied on this beam, and the live load, this one and this one, will be added, and the total will be here. In the same way, here the dead load 14 and here the dead load 18 will be added, and the total dead load will be here, and the live load 7.7 and 8.00 will be added, and a total of maybe 15.7 kilonewton per meter live load will be applied here. Now let me show you how things is going on. The sum of the two dead loads here will be 43.2, and the live load will be 18.66. Now some students asked about the load transfer length. Okay, we said that the load transferred from the slabs to the beam will be applied on the middle 0.75 of the span of that beam. Now let's see how this is going to be. Now I will take this axis B, the beam on axis B, as a sample, and I will show you how you transfer the load on that beam. Now you have seen this much is dead load, this much live load on this span, and this much dead load and live load on this span. Now I will assume that the columns are pin support, okay, pin support, and I will show you how you transfer the load. Now this is my beam. We see here that this beam has a span of 3.85 center to center and 6 from here up to here. So now here, this is my span length. Now I need here the middle 0.75 L. 0.75 L. Now this is my 0.75 L, means 3.85 for this span, so the total of 2.89 meter will be here. And here the same 0.75 times 6 is the span, and I have 4.5 in the middle. Okay, now the remaining part, what will happen? For example, here 4.5 is the middle span of where we are going to distribute the load, and the total is 6. Now 6 minus 4.5 will be 1.5. Now half of 1.5 and half of 1.5 will be here. It will be 0.75 here and 0.75 here. In the same way here, 3.85 minus 2.89 will be 0.96 something. Now half of it 0.48 and half of it 0.48 will be this span. This is what I am talking about. 0.48 from here up to here, and 0.48 from here up to here, and 0.75 from here up to here, and 0.75 from here up to here. Now let me show you how you are going to distribute the load. The load will be applied like this. The dead load is 23.26 in the middle 0.75 of the length of this beam, and the live load will be here also 12.32. This is 12.32, this one. The 23.26 is here 23.26. Now this will be applied in the middle 0.75 of that span. Okay, in the same way here the dead load is 43.2, and here I have 43.2, and the live load will be 18.66. This is what we have been calculating, the load transfer from panel 2 and from panel 4. Now once you have this loading, either you can use hand calculation or you can use softwares, and for this condition you will calculate or you will determine the bending moment diagram and the shear force diagram for this beam, and you are going to design the beam for the loading, for the flexure and for the shear, and maybe if you have torsion due to many reasons, you have to calculate and design this beam for the applied stresses. Okay. Now, do not forget that this beam, when you are analyzing this beam, you have to consider the different loading patterns, okay? For example, when there is live load here and there's no live load here, and when there's live load here and there's no live load here, when the whole beam is loaded, and so on, okay? The different loading conditions must be considered to obtain the worst scenario for which the beams are going to be designed, okay? Okay, I think this answers the questions raised by some of the students. That's all for this video. If you have any question, please write in the comment box. Thank you for watching. See you next time.